Okay, so today we're going to continue with section 9.3. So first we're going to talk about our reference angles, and you're going to see this symbol a lot. It's called theta prime. So it's not exactly the same as theta, even though it's the same symbol. This prime sort of means even though they're on the same quadrant and such, that's the differentiating factor, is this prime symbol. So you'll see this theta prime and you'll see this reference angle relationship when you are working with quads 2, 3, and 4. So not quadrant 1. So basically it's saying it's between 90 degrees and 360 degrees. So quad 2, quad 3, and quad 4, not quad 1. Okay, so when an angle is in quadrant 2, that would maybe look something like this, right? So your angle is in quadrant 2 and your theta is this. So that's what we're used to. Your theta is the actual angle going on here. Your theta prime is sort of the leftover spot between your angle and 180 or quadrant 2. So as far as finding that extra angle, you take 180 minus theta. So whatever this angle is, minus 180 will give you this little leftover piece. If it was radians, it would be pi minus theta. And let's just quickly talk about radians like that. So this would be obviously 0. This is pi over 2. This is pi, and this is 3 pi over 2. Or 0, 90, 180, 270, 360. All right, so in quadrant 3, that would be if an angle looked like this, quadrant 1, 2, 3. So here is your theta. So it's saying this whole piece is your theta. So then this piece is your theta prime, finishing up the rest of the angles. So as far as degree goes, you're going to change it up a little bit. You're going to take theta minus 180. And why you want to take theta minus 180 is because this is going to be a bigger angle than 180. So this prevents us from getting negatives. Or theta minus pi. All right, and the last one, quadrant 4, the angle will be something like this. So theta is this whole big piece. And theta prime finishes it off. So this one, again, we want to avoid negative, so it's going to be 360 minus theta, or 2 pi minus theta. So you're going to use this a lot. This is also in the reference sheet that I added to the Google Drive yesterday. So keep that in mind. This is going to come in handy. All right, so let's start with the first one. So we have theta prime being 5 pi over 3. So there's a couple of different options here. If you don't like working in radians and you would like to change it to degrees, you can. Remember 5 pi over 3, if we wanted to turn it into degrees, we want to get rid of pi. So pi is on the bottom, 180 is on the top. You want to reduce as much as you can. 3 goes into 180 60 times. So it'd be 300 degrees. This also gives you an idea, I think, of which quadrant it's going to be in. So if it's 300 degrees, it's going to fall in quadrant 4. So it's going to be between 270 and 360. So falls in quad 4. That'll come in handy later. Okay, so let's see. So like I said, you can use either radians or degrees. For now, let's keep it in radians because it's in radians, but like I said, this will give you a good idea of where it is. So we're going to take quadrant 4 would be 2 pi minus theta. So we have 0, pi over 2, pi, 3 pi over 2. So it's going to fall somewhere in here between 3 pi over 2. Oops, sorry. So we'll take 2 pi minus 5 pi over 3. Remember, whenever you're subtracting fractions, they have to have like denominators. So you turn 2 pi over 3. You need to make that 3. So you multiply it by top and bottom by 3. And you get 6 pi over 3. Then minus your original 5 pi over 3. And you get pi over 3. Sorry. So therefore, pi over 3 is theta prime. All right, so let's look at the next one. It does give us a degree, but it gives us a negative. And remember, up here we discussed that it's got to be between 90 and 360. So it has to be in one of these quadrants, and it cannot be negative. So must be positive. So in order to find a positive angle that is in that exact same position, remember the word coterminal. So negative 130 plus 360 will just give us another variation of this, but the positive version. And we get 230 degrees. Okay, so let's look and see where 230 would fall. Not in quadrant 2 because that's 0 to 180. Quadrant 3 would be 180 to 270, so it is in quadrant 3. So if that's 270 and that's 180, it's going to be somewhere in there. So in quadrant 3, our rule is theta minus 180. So it'd be 230 minus 180, which is 50 degrees. Not too crazy. All right, so on to example 4. So I have the steps here for you as well as the chart. So the first one says find the reference angle theta, which we just did in example 3. So that sort of first step is covered with what we just did. Then you're going to evaluate the trig function. And then the third step is to determine the sign. What that means is once you determine what function you're using, which they will give to you, you have to figure out which quadrant your reference angle is in, and that'll determine whether it's positive or negative. So like I said, this is all in that reference sheet I gave you, not something you necessarily need to memorize. Okay, so let's get started with this. So we are given tan of negative 240. So again, with tan of negative 240, we cannot have negative degrees. So we are saying that, okay, if we have that, we need to find a positive coterminal angle. Yeah, I'm just going to bring this up for now. So find our positive angle. We have negative 240 plus 360, which gives us 120 degrees. Okay, so that is now what we are working with. So then let's find our reference angle. So if we're working with 120, we know that's in quadrant 2. Quadrant 2 in the first page told us 180 minus theta. So we take 180 minus 120 and we get 60 degrees. Step 3, so we've now found our reference angle. Now we need to evaluate the trig function. So how we evaluate the trig function is we say, okay, tan of 60. So we use what's given, now our reference angle, tan of 60. you're going to look back at this chart. Oops, bringing that green chart into play. And you're going to use this piece. I've also attached this to today's Google Classroom. So tan of 60 is the square root of 3. All right, so step 3 says determine the sign of the trig function. So it lies in quadrant 2, and it's tan, quadrant 2, tan, negative. So tan of negative 240, therefore equals negative square root of 3. So it's a little bit goofy as far as it takes a couple steps to get through, but not too bad. All right, so let's look at the next one. Cosecant of 17 pi over 6. So again, with this one, change it into degrees. Might make it a little easier for you to see. So 17 pi over 6 multiplied by 180 over pi. Cancel out your pi's. We know 6 goes into 180 30 times, and then 17 times 30 is 510. Okay, so now we have 510. Again, we need something between 90 and 360. So 510 does not work for us. So just like our angle where we had to add 360 to get it, because 510 is bigger, we're going to subtract 360. So 510 minus 360 gives me 150 degrees. Now we're back in action. This now works. And it's also in quadrant 2. Okay, so in quadrant 2, we still need to find our reference angle. So just like we did, because this one was in quadrant 2, 180 minus theta, we'll do 180 minus 150, and that gives us 30 degrees. And then we go to our chart, and we're now taking the cosecant of 30 degrees, which cosecant of 30 equals 2. Therefore, cosecant of 17 pi over 6 equals 2. That's your lesson.